An introduction to the AC sine wave. To understand a specific waveform of AC, we must first understand the basics of it. AC stands for alternating current. Alternating current is when the polarity reverses over a period of time t. Due to this relationship, it can be represented as a function of various different waveforms, today of which we are focusing on the sinusoidal wave. Every AC function has a set of characteristics which include a frequency or cycles per second in units of hertz. Peak-to-peak voltage, which represents the maximum value of voltage the function will reach in units of volts. DC offset, which is an added DC voltage that offsets the centerline of the function from the x-axis, however does not disrupt the amplitudal period and thus frequency of the function. And finally, a phase shift measured in reference to an AC source, in units of either absolute time or units of angle like degree and radians. When an AC wave exhibits quarter wave symmetry, i.e. each quarter in time of the wave is symmetric to the next, it can be modelled mathematically as a sinusoidal function of voltage over a period of time. The implementation of the aforementioned characteristics will result in a function seen when the exact voltage at time t is equal to the peak-to-peak multiplied by the sine of the angular frequency plus or minus the phase shift. If present, a DC offset is then added onto the back of the function. Phase shift requires the delay between the measured voltage to the AC source. To generate and supply circuitry with an AC source, a function generator is used in laboratory settings which will output a waveform function based on the function selected in inputted characteristics. A standard digital multimeter cannot accurately provide voltage measurements of an AC current, so thus we use an oscilloscope which displays the function on a two-axis plot, with the x-axis representing the amount of time the plot represents and the y-axis representing the voltage. As an oscilloscope will typically allow for 2 to 4 maximum channels of measurements. 1 to 4 different measurements can be represented as the function, allowing for easy representation of phase shift and DC offset, in comparison of how AC interacts with simple and complex circuit designs. Enjoy the wizardry of AC with this basic knowledge. If you wish to gain a better understanding or more knowledge of AC, then the listed sources below are helpful. Thank you.